So now that you have the big picture view of how to group completion stage methods, let's start diving into each of these categories, subcategories, and we're going to start by taking a look at how single stage completion methods can actually be used in practice. So we're looking at just this group, and I broke this up into two parts because there's a fair number of methods that do this, and I want to talk about them. This part one of this lesson, we'll talk about thenApply and thenCompose. Those are very common methods. So remember, these are methods that are triggered by the completion of a single previous stage. And we'll start by taking a look at thenApply. So thenApply applies a function action to the results of the previous stage. So there's one stage that comes before this. That function will be applied when that previous stage completes. This could be something like supply async, which starts things asynchronously, as we'll see, and then you could do thenApply when that's done. It returns a completable future that contains the result of the action. You can see here, I used the word future just because it's easier to get on the slide, but it's a completable future. And the typical use case for this is to perform a quick synchronous action that returns a value rather than returning a completable future. So let's take a look at a very simple example. You've seen variants of this before. We're going to start out by making a big unreduced fraction, so a big fraction that's unreduced. So it's got a big numerator, big denominator. Both of those are big integers. And then we're going to go ahead and make a supplier that will reduce this big fraction, because reduction takes a while. And then we're going to go ahead and call supply async, the factor method, passing in this supplier, which will then reduce it in the background. And when it's done reducing in the background, then we're going to apply this method to convert the improper reduced big fraction to a mixed big fraction, or a mixed string. So that'll return a string value. So that's going to typically run in the same thread that did the reduction in the background, and then we're going to apply it. And then apply returns a completable future. And notice this call turning an improper but reduced big fraction into a mixed string is fairly quick, so we do that synchronously running in the background. And this example appears here in the EX folder in my Java 8 project in my live lessons repository. All right, let's talk about thenCompose. So we'll first explain what it does, and we'll explain why we need it. So thenCompose is also triggered when a single previous stage completes. And it also takes a function, so that looks very similar at first glance to thenApply. It returns a completable future that contains the results of the action directly, rather than a nested completable future. You might go, what the heck is he talking about? I'll explain in a second. The easiest way to think about this conceptually, before we dive into the details of how it works, is to realize that thenCompose is quite similar to calling flatMap on a stream or calling flatMap on an optional. When you call flatMap on a stream, as you recall, it will basically denest things. So if you had a stream of search results, when you flatMap, you'll end up with a stream of search results. Or if you had a stream of strings, or stream of integers, or whatever, or a stream of lists of integers, and so on, it'll denest the stuff. So very similar concept with thenCompose. So let's take a look and see what the heck is going on here. So were you to use thenApply and you were trying to do something with two completable futures, you would end up with nested completable futures, which, as we'll see when we look at it syntactically, is very, very jarring visually to see and understand. But when you use thenCompose, you end up with a completable future to the value rather than a completable future to the value. So let's take a look at an example that will make this a lot more clear. So what we're going to do here is have a long duration async action that returns a completable future. Remember when we talked earlier about thenApply, we had a shorter synchronous action that returned a completable future. Now we're going to have a longer running async action that returns a completable future. So in this case, we're going to create ourselves a function that will take a big fraction, which I abbreviated so it would fit on the slide, and a completable future to a big fraction. And this is called reduce and multiply fractions, which is going to call the supply async method. And in the action part, it'll reduce the unreduced big fraction. So that's what it's doing in the background. Note that this returns a completable future. So Remember, supply async returns the completable future. So far, so good. Here's what we're going to do now. We're going to use thenCompose, and we're going to say, notice how these are chained together. So supply async followed by thenCompose. When we finish reducing the BigFraction in the background, then we're going to take that reduced BigFraction, and then we're going to asynchronously multiply the reduced BigFraction in the background. And because that could also take a while, we're going to run that asynchronously as well. So the first call up here runs asynchronously. When that completes, we then run another call asynchronously. But notice that in this case, supply async returns a completable future. So if we were not using thenCompose, we could end up with a completable future to a completable future, which is not what we want at all. But thenCompose flattens that. So we'll take a look later to see some other issues here and how to avoid the problems with composition in ugly ways. You'll see that shortly. OK, so that's the end of part 1 of this discussion.